Guys, what is up? Welcome back to the DSA sheet of Morgan Stanley that we are solving, that is provided by Geeks for Geeks. And in today's video, we are gonna see a very interesting question that is spirally traversing inside a matrix. See, this question comes into picture when we are studying the traversal inside a 2D array. So when we are first starting out with 2D array, this question comes into picture and we generally tend to skip this question because it seems hard. But let me tell you one thing, this question is not that hard. We just have to pay a little bit of attention and little bit of attention to the details. Then we can just do this question with snap of the fingers. So before jumping on to the solution, we'll have to see the question. But let me tell you one thing, that into this video, the solution that we are going to see will not be so cool in terms of space, but it works. It passed all the test cases. So it is the most interesting solution that I can think of right now. So we'll just follow that solution. So if you guys know any solution that is more optimized, you are free to do whatever you want. I am free to do whatever I want. So let's just see the solution. But before that, let's just jump onto the question. So this is the question, spirally traversing in a matrix. You are given a rectangular matrix of size n cross m, okay, and your task is to return an array traversing matrix in a spiral form. We can do it. We have to traverse in this manner that is shown to us inside in the figure. So let's just see. So let's just take this example. This is a 5 cross 5 matrix. And what we have to do? We have to do a spiral traversal inside it, right? So how are we going to traverse? We're going to start from here. Then we go down. Then we'll do this, and this. This is how we are supposed to traverse inside this matrix. Right. Now we have to just observe some things. What you guys can observe here? Let me tell you. We are starting from a direction, and at some point we are changing our direction. Suppose we started from right, that we will actually start from right. You don't have to suppose, we will start from right. So we started from right, and at some point we changed our direction and we go down. Okay. And at some point again we changed our direction and we go left. Right. Then again at some point we go up. Then again we go right, and this cycle continues. So one thing we have figured out, that we are starting from a direction, then at some point we are changing our direction. Cool. Now the only thing to think is that when are we changing the direction? Can you guys tell me? When are we changing our direction? We are changing our direction as soon as we hit the boundary. But is it the only condition? We are changing our direction at this point too, this point too, here. These guys, let me just erase the boundary ones. These guys are not boundary. So we are changing our direction 1 when we hit boundary. And number 2, when we hit a node that was already visited. That's it. This was the trickiest part that we guys had to see, and it is not tricky at all. We just had to observe some things. Number 1, we are changing our direction when we hit the boundary. And number 2, we are changing our direction when we hit previously encountered element. That's it. Now we can solve this question. One more thing. Till what time we are running inside the matrix. It is n cross m times. That's it. Now let's just jump into the coding part and see this all in action. So this is our question, right? And first thing first, let's just get the size of the matrix. Now what we have to do, we have to understand the direction. So let's just create two vector int row direction that will be equal to something, and vector int call direction that too will be equal to something. Now we are starting with right. Let me just write it. We go right first, then we go down, then we go left, then we go up. So when we are going right, what is changing? The column is changing. So row is not changing and column is changing, and it is changing by +1. Cool. When we go down, the row changes. Again, the row changes by +1 and the column remains same. Then we go left and the column changes, but the row remains same and column changes by -1. Okay. Then we go up, the row changes by -1 and the column changes by 0. So we have figured out the concept of directions. Now let's just declare two variables, current row, initialize it with 0, and int current call. Again it will be 0 because we are starting from 0, 0. And let's just create a loop for int I equals 0, I less than size, I plus plus, because we are doing a spiral traversal for all the elements inside the matrix. And now let's just see. First thing first, we have to create a visited array also. So what I'm going to do, I'm going to do a vector. It will be of Boolean and it will be a visited vector, and the size will be mat.size, vector int mat0.size, and all values will be false. Okay, so first thing we should do is mark the visited of current row, current call to be true. Okay, now what? Now we have to determine the next row. So what will be the next row? Next row will be equal to current row, and it will be equal to, let's just keep a variable direction also, int direction. Initially it is 0 and plus direction. We are changing the row, right? So row dir, and here we will do direction. Next call equal to current call plus call dir and direction. So we have determined the next row and next column. Now what? Now we have to check, do we have to change the direction or do we have to not change the direction? So I will deal the changing direction part in the else. So what we are going to do, we are just going to see if the next row is greater than equal to 0 and next row is less than total rows. So let's just declare the total rows too. Int rows equal to mat dot size. Int calls equal to mat 0 dot size. Okay, and next call is greater than equal to 0, and next call is less than total number of calls. This is for the boundary condition, right? Now we have to check that the visited of next row and next call is equal to false. Then only we will proceed, otherwise we will change the direction. So if we are proceeding, so what we'll do, we will set the current row to next row, and we will set current call to next call. Cool. And in the else part, now what we have to do? So in the else part, we have to change the direction. So we will change the direction equals direction plus 1, right? It will be 0, 1, 2, 3, 4, and then we will do a modulo 4 because we don't want our direction to exceed the 3. It should be 0, 1, 2, 3. So that's why we are going to do a modulo 4. And after changing the direction, what we'll do, we'll just update the current row equals row direction, and it will be dir, and current call will be equal to call direction, and it will also be dir. Cool. And one thing I forgot to do, that whenever we are visiting, we have to push it to answer. So let's just declare a vector of int, and it will be an answer vector, and we'll just push answer dot push back, and we will just store the matrix current row current call. Cool. That's it. And at the end of the day, we are going to return answer. Hopefully this code runs fine. So it is giving some compilation errors. So the issue is that here we are doing int, we have to do bool. And one more thing I have noticed, that here we have to add a plus because we are adding the offset, right? It is same as these two lines, but we are just directly changing the current row here. So that was one thing, and let me just see once more. And I have to declare next row and next call also. That's it. I think now my code should work fine. Yup. And now we can submit the code and see, does it pass all the test cases? And yes, it passed all the test cases. So this solution indeed was not so cool in terms of space, because we are declaring a vector of vector again of the size of matrix, but still it works. So it works, and I am free to do whatever I want. You are free to do whatever you want. I just wanted to tell you guys that we can solve this question in this manner too. So thanks for watching, guys. See you guys soon in the next video. Bye bye.